Hello, everyone, and welcome to our first episode on our new series on ZNotes Live. I'm your host, Yukan. I'm here with Devandhira, and in this series, we will do all the math papers from this year's May-June 2020 exam. On our first episode today, we'll start with Paper 1 from IGCSE Admaths Variant 2. On to you, Devan.
Okay, thank you so much, Yugan, for being with me today. So, as Yugan said, I'll be the expert um, in the series. So, for this episode, we'll be starting off with May June 2020's Additional Maths. Sorry, and sorry for the delay. I really had a lot of Wi-Fi problems. Even right now, it's it's not okay. Yeah, it's not okay. Even right now, it's not okay. The screen's not moving. It's barely moving. Oh God.
Oh no.
Yeah, it's barely moving. Uh, I, I've made it to the next episode. Next page. But there you go. Okay, so let's get started.
Okay,
So,
okay.
so this is the formula sheet that you'll get when you take the exam. If you've done the past papers before, you'll be familiar with this, except for one part. Oh my God, stop moving again. So this part is the arithmetic series and the geometric series, because this is new in the syllabus. So they've given you formulas for it, like the nth term, the sum of nth term of each series, and so on. So let's head for the first question. All right. So for number 1, on the axis below, sketch the graph of y is equal to the absolute value of the product x minus 2, x plus 1, and x plus 2, showing the coordinates of the points where the curve meets the axis. Okay. So first thing, what kind of graph is this, Yugen?
This should be a cubic graph.
Why is that?
Because there are 3 linear x factors multiplied together.
Oh my, it got disconnected.
Oh.
This is not good. This is not good. All right. It's going to load a while, so I guess we can just do some explanations. So as Yugen said, there are 3 x... Sorry? X what?
Linear x terms.
Oh, okay. So there are 3 linear x terms being multiplied together. So we get an x cubed term. Is that correct?
Yeah.
All right. But can I move my screen now? I still can't move my screen. This is so hard. Yeah, I can't move my screen.
Can you write?
Even writing doesn't work. Yeah. The writing doesn't work. Yep. Oh my God. So basically, how you would draw this is that since... Oh my God, it's updating really slowly. Okay, there you go. Okay. So, because it's convenient for us that they've already written it in the product form, in the factorized form. So that means their roots are just 2, minus 1, and minus 2. Is that correct, Yugen? When I mean roots by when they are 0. So it's when x is equal to 2, minus 1, and minus 2. So that means that this graph will intersect these coordinates right here. Is that correct? Okay.
Yeah.
So let's mark them first. So we have minus 2, minus 1, and let's put 2 here. It's not updating again. Okay, there you go.
Okay, there.
Yep. So how does a cubic graph look like, Yugen?
A cubic graph will have, on one side, it'll be either decreasing or increasing, and then after the roots, it'll be going in the opposite direction.
Exactly.
A typical one would have like 2 turning points.
Yep, 2 turning points. So if you were to draw the graph normally without the absolute value, Let's draw the coordinates again. -2. So because this is positive, if you multiply the product, you'll get a positive x cubed term. That means the graph will be positive at the positive end, while negative at the negative end in the left side. So if you'll draw it, you'll maybe look something like this. Do you agree, Yugen?
Mm-hmm.
Okay. But because of the absolute value, that means everything in the negative side is reflected upwards. So let's try drawing that. I'm sorry, I'm not a good artist, so I'll try my best to draw it. Okay, something like that. Okay, are we done?
Uh, no, it says to mark the points where they meet the axis, and there's no
Mm,
marking on the y-axis.
exactly. So what's the y-axis? What should we do to find the y-axis here? Oh
So
my!
along any point on the y-axis, x is 0, so we can sub that into our equation.
I'm sorry, this takes a while. This is a disaster. Wait, let me try changing Wi-Fi.
All right, we'll be back shortly, I guess.
I'm sorry, it's really hard to handle this. Hello?
Yeah, I can hear you. The stream is
Okay,
fine.
so hello, Yugen?
Yeah, hi.
All
Your
right.
camera's fine. The stream is working.
Okay, so as Yugen said, we have to let x become 0, is that correct?
Yeah.
All right, so let's let x become 0 here. And we'll find the product. So we have -2 times 1 times 2. This is y is equal to -4, absolute value, which is just 4, right? Agree?
Mm-hmm.
All right. So remember, when you have absolute value, you don't care what's the sign of the number. Whether it is, if it's negative or positive, you always take the positive. Is that right, Yugen?
Yeah.
Sorry?
Yes.
Oh, okay. All right, so let's put 4 here and we're done. So
Mm-hmm.
we're done with the first question. And let's go ahead for the next one. Oh, fuck. Hello?
Yeah, hello.
Okay.
I still can't see the stream. Oh, there we
Wait.
go.
Yeah, it keeps disconnecting sometimes. And this is delayed right now. Oh, okay, it's not delayed anymore. Okay, let's start. The volume V of a sphere of radius r is given by V is equal to 4/3 pi r cubed. The radius rcm of a sphere is increasing at the rate of 0.5 centimeters per second. Find, in terms of pi, the rate of change of the volume of the sphere when r is equal to 0.25.
Hmm.
Okay, wait. What? Life is hard, sir.
Life is hard.
It's so hard to connect. If I use the other Wi-Fi, it doesn't work.
Mm.
Is it delaying? Yeah, it has so much delay. I can't move the screen. This is my second Wi-Fi.
Ah, okay.
Oh my god. Okay. Hello?
Yeah, hello?
Let me try connecting again. Hmm. I'm so sorry about this. Okay, it should be okay now, right?
Oh, yeah, it's moving, it's moving.
No, it's not okay anymore.
Oh,
It's
it moved.
it moved, but it's so slow. Okay, I guess this is okay right now. All right, let me reread the question again. The volume V of a sphere of radius r is given by V is equal to 4/3 pi r cubed. The radius RCM of a sphere is increasing at the rate of 0.5 centimeters per second. Find in terms of pi the rate of change of the volume of the sphere when r is 0.25.
Yeah,
Is it okay? Oh my god, it's not moving
yeah,
anymore.
it's
All right, so
when
Yugen, what kind
you.
of question is this? What do you think?
All right, so this is a rates of change question.
And all right, so from the question they ask us to find the rate of change of the volume. Is that correct?
Mm-hmm.
All right. So that means we're trying to look. What we're looking for is dv dt. Is that correct?
Yeah.
This is what we're looking for. But how do we find dv dt?
We can use the chain rule and find
Mm-hmm.
something with dv and dt in it.
All right. So from the question they gave us, the radius of a sphere is increasing at the rate of 0.5 centimeters per second. That means that is the rate of change of the radius, correct?
Mhm.
All right. That means that's dr dt. Do you agree? Rate of change of
Yes.
rate of change of radius over time, which is 0.5 centimeters per second. All right. Now, from the chain rule, as you said before, even
Mm-hmm.
if you want to connect these dv dt and dr dt, we need to look for a dv dr. Is that correct?
Yeah.
So as you can see that the dr here cancels, and you're just left with dt. But what's dv dr?
You have an equation of v in terms of r, so you can just differentiate that.
Exactly. So we have v is equal to 4/3 pi r cubed. So let's differentiate that. The VDR is 4 pi r squared. That's by the r rule. And let's put that in. 4 pi r squared multiplied by 0.5. Everything okay so far?
Yeah. You can
All right.
simplify that to 2 pi r squared if you want.
Yeah, sure. Let's do that. But are we done yet? Like,
No, The question says R is 0.25.
Exactly. That means we have to plug in r squared 0.25. So let's do that. 2 pi multiplied by 0.25 r squared. And at this point, you can just use your calculator and evaluate this. But the answer is just 0.125 pi. And don't forget the units. This is the rate of change of volume, so it's centimeter cube per second. And don't forget to box your answer. Everything okay so far?
Yeah, this is fine.
All right.
For the viewers, you can also leave your answer in fraction form pi over 8 if you want.
Exactly. So let's move on. Oh, binomial theorem question. Okay. Find the first three terms in the expansion of 4 minus x over 16 power 6 in ascending powers of x. Give each term in its simplest form. All right. So recall that the binomial expansion is in this form: a plus b power of n is equal to a to the power of n plus n choose 1, a power n minus 1, and b. For those of you who don't remember, it's okay because they have it in the formula sheet right here. Right, Yugan?
Yeah.
So you don't really have to remember it, but if you don't remember it, there's no problem too. But let's move on to the question again. And so on. All right. So let's find the first three terms. Let me put this here. Sorry, it's not a plus. 16 power 6. All right. So what's the first term, Yugan?
It'll just be 4 to the power of 6.
What about next?
Then it'll be 4 to the power of 5 times negative x over 16 times 6 choose 1, which is just 6.
Exactly. Let me just give a space. Let's choose 1. Okay. What about the next term, the third term?
And then that'll be 6 choose 2. 4 to the power of 4
multiplied
times negative x over 16 squared.
Exactly.
All squared.
Yep. All right. So another note for the viewers is that if you notice their power right here, there should be one here, and this one, they always add up to 6 in each term. Right, Yugen? They always add up to 6. They always add up to the power here, the n. So if you somehow didn't get a 6, then I think that's a hint that you're making a mistake somewhere.
Yeah.
All right, so let's move on. We can just use our calculator for this. So what's 4 to the power of 6? That's
4096.
When we simplify this, don't forget that there's a negative sign here, so we'll have to put negative. And 6 times...
That'll be 384.
Oh, 384, okay. 384x. And what about the next one?
Give me a sec.
Okay.
1 over 16 squared. That'll be 15. Pop up.
All right.
Pop up.
Oh, sorry. Pop up. All right. 15x squared. Okay. So since we only need the first three terms, are we done?
Yeah. It just says first three terms in ascending power, so we have that already.
Okay, exactly. So don't forget to box your answer. And we're done. We got 3 marks for that. Next one. Hence, find the term independent of x in the expansion of this expression. So what does it mean when something is independent of x?
That means it isn't affected by x, so it's just a constant.
Exactly. So these type of questions with hence usually refers to the question before. Is that correct? That means we'll have to use this. The reason why they ask for the first three terms is that they will use this answer, what you got, to replace the power here, the expansion from the first question. Is that correct, Yugen?
Mhm. Yeah,
All right.
yeah, that's usually the case.
Mm-hmm. So let's do it. Let me just copy everything here. Make sure not to forget anything. Don't leave anything behind. And we can also expand this. What do you get from expanding this, Yugen?
You'll get x squared minus 2
Minus two.
plus 1 over x squared.
All right. X squared. Exactly. So because we're only looking for the term independent of x, I just have to look for the terms when you multiply. You'll get no x at all. Right,
Mm.
Yugen? All
Yeah,
right.
yeah.
So for me, I can see that if I multiply 1496 with negative 2, I won't get an x. Is there anything else, Yugen?
You can multiply 15x squared by 1 over x squared. The x squares will cancel, and then you'll get
Exactly.
what you want.
Exactly. So we have 15x squared multiplied by 1 over x. The x squares will cancel, right? They divide each other.
Mm.
So we just have to put plus 15. And we can simplify this. What? Just put in your calculator, you'll get the answer to it.
Yeah, you'll get negative 18177.
177. Okay. Box your answer, and we're done.
Hmm.
6 marks. All right, 6 marks for this page. Very good. Okay, next one. Oh, permutation combination. Find how many different 5-digit numbers can be formed using the digits 1, 2, 3, 5, 7, and 8. If each digit may be used only once in any number. So
Hmm.
out of these 6 digits, right, we have 6 right here. We only care about 5. Right, Yugen?
Yeah.
So we need to look for how many different 5 digits number we can form. That means the order matters, correct?
Mm-hmm.
Okay. And so what do you think we should do here?
Um. So you should see how to say. You have basically 5 slots where you can put your numbers in, and you have
All
six
right.
numbers, and the order matters. So you must use permutation. Devan? Devan, hello?
Yeah, hello. Sorry, I disconnected again. So what did you say
Oh,
before?
all right. Um, yeah, I said you have basically 5 slots for your numbers, and you have 6 different numbers, and the order
Mm-hmm.
of them matters. So you must use permutation.
Exactly. So we'll have so out of the 6 digits, we'll only take 5. That means we'll have to do 6 permutation with 5. What's that? I think that's 720. Is
Yeah,
that right? All right. Box your
yeah.
answer. How many of the numbers found in part I are not divisible by 5? So how can we look for this?
You can find any of the numbers that are divisible by 5. So that means they end in 5 or 0. And you can your initial answer from I subtract with that.
Exactly. So because there's no 0 in our digits, that means we only have to care about the 5, correct?
Mm-hmm.
Okay, so we have our last slot is filled with 5. We have 5 digits left and we care about 4. So that means we have 5 permutation with 4. That is 120. Is
Mm.
this our answer, Yugen?
No, no. That's
Oh,
the amount of numbers divisible by 5.
so that means we have to subtract by our previous answer, correct?
Yeah.
Okay, so we have 720 minus 120. That is 600. Is this our final answer?
Yeah.
Okay, then don't forget to box your answer. How many of the numbers found in part I are even and greater than 30,000? Okay, so let's put 5 slots here first. So greater than 30,000 means that this digit right here, the first digit, has to be 3, 5, 7, or 8. Agree?
Mm-hmm.
Now, what does it mean when it's even?
So that means it's ending in an even number, which is 0, 2, 4, 6, or 8.
Exactly. But in our case, how many even numbers are there?
There is only 2.
Okay, which is 2 and 8, correct?
Mm-hmm.
Okay, so let's first start with the smallest possible even number, which is when the first digit is 3 and the last digit is 2, correct? We'll have to
Mm-hmm.
split this into situations, into a few cases. So let's do that. When the when the last digit is 2 and the first digit is 3, and we'll keep doing this until we reach our highest number. So 5,
Mm.
2, 5, oops, 8. We'll have 7, 2, 7, 8, and wait, sorry, not 7 again. We'll have 8 this time and
Mm-hmm.
2.
Mm.
Why 8, Yugan? Do we have to count that? Oh,
No, no. Because we don't have to count 8, 8 because you can't repeat the number. So you just have 7 different possibilities.
hey man, hello.
Mm-hmm.
All right, let me try connecting again. Okay, sorry about that. So, as I was saying, do we need to care about when the first digit and the last digit is 8?
No, no.
Why?
Because it says we can't repeat any numbers.
That's correct. So now, since we have 7 situations here, and let's take a look at the first one. How many digits are left when we put 2 digits here?
Um, so there are 3 digit slots and we have 4 numbers.
Sorry, we have 4, and we only care about
We have
3. Is that correct?
Yeah, yeah. The order still
Okay.
matters, so we must use permutation.
Okay. So for the first one, we have 4p3. Do you agree then?
Yeah.
Okay, which is 24 if you bring a calculator. But if you take a look that each cases, this is the first case, second case, third case, fourth case, and fifth case, sixth case, seventh case, so on. All of them are also 4p3.
Mm-hmm.
Isn't that right? That means we just have to multiply 24 times 7, which is 168, right?
Yeah.
All right, and this is our final answer. So don't forget to box it. Next one. The number of combinations of n items taken 3 at a time is 6 times the number of combinations of n items taken 2 at a time. Find the value of the constant n. Okay, so let's figure out what the question is saying. We have n items taken 3. What does that mean?
That means n choose 3 or n
Okay,
combination 3.
yeah, n choose 3, but I prefer writing this way. It's up to you. Is equal to 6 times the number of combinations of n taken at 2. Taken 2, sorry. So that means it's
Pop up.
6 multiplied by n choose 2, correct?
Pop up, Devan.
Oh, sorry. Yes.
Yeah.
So, like this, right?
Mm-hmm.
Okay. So how do we solve this? What do you think? How do we
Uh,
solve this?
you can use the combination formula to expand both of them.
Exactly. So for those of you who don't know, that n choose r is also the same as n factorial divided by r factorial multiplied by n minus r factorial. Do you agree with this?
Yeah, yeah.
All right. So let's use that. So for in this case, our r is 3 and our r is 2. So let's just replace it and factorial. This may take time. Sorry. And 6. Better not to forget anything. 2 factorial. Okay. Everything okay so far?
Mm-hmm.
All right. So what should we do next? we're already in this form, and what should we do next? What's our next move?
So, well, from here is just straightforward. You can simplify it. You can cancel the n factorial, and then you can expand n minus 2 factorial.
Exactly. So we can divide both sides by n factorial. That's right. Nice one, Yugan. And what's the next one? We can expand who?
N minus 2 factorial.
N
You can
minus 2
also
factorial.
inverse it to make it linear.
So how do we expand the n minus 2 factorial here?
So, by definition of factorial, that would be n minus 2 times n minus 3 factorial.
Exactly. So for those of you who don't know, n factorial can be written as n multiplied by n minus 1 factorial. So, a small example is like 5 factorial can be written as 5 times 4 factorial, because 4 factorial is just 4 times 3 times 2 times 1. Then you multiply by 5, you get 5 factorial. Correct?
Yeah.
All right. So I'll delete this part. Okay. So we'll apply the same thing. Let's simplify also on the way. 3 factorial is 6, and minus 3 factorial is equal to 6 over 2. 2 factorial is 2, and minus 2, and minus 3 factorial. And from here, I think we can multiply both sides by n minus 3 factorial, correct?
Mm-hmm.
And we can cancel it. Cancel. And let me just write everything again. 6 divided by 2 is just 3, and n minus 2 right here. Everything okay so far?
Yeah.
Okay. So from here, you can just cross multiply and solve it manually. We have n minus 2 is equal to 6 times 3, which is 18. The transfer 2 in your side, n is equal to 20. This is our final answer?
Yeah, that's our final answer.
Okay, it's correct. And that's 4 marks for you. Let's move on to the next question. There's functions, okay. So f of x is equal to 2x plus 3 squared. Find the range of f. So how can we find the range of f?
So the range of f is the values the function f of x is for the domain x is more than 0, or any given domain.
Yep, exactly. So the range is the possible y values of the function given the domain, correct? Under the domain, what kind of function touch in the y value, correct? All right.
Yeah.
So how can we find it? How can we find the range?
So one way one can think about finding the range is trying to visualize how the graph looks like first.
Yeah, you can do that. So we can draw the graph first. Let's draw it here. So when will this is a quadratic graph, correct? It's a x squared graph, quadratic graph. When will the graph touch 0 here?
So it would touch 0 if you equate it to 0. You would get a negative 3 over 2, or just negative 1.5.
So negative 3 over 2, correct?
Mm.
All right, so that means negative 3 over 2 is somewhere here. And the graph would look like this. Do you agree?
Yep.
Okay. So let me just delete this part. It won't be too messy. All right. So based on the question, it says that for x greater than 0, that means that we don't have to care anything behind that at the when x is less than 0. Is that correct? That means we only have to care about this part.
Yeah, that's correct.
So how can we find this?
So we can see that the lowest point in the graph is when x is 0. So we can substitute that into our equation.
Okay, so we have f of 0 is equal to 2 times 0 plus 3 squared. Okay.
And then that's just 9.
Exactly.
And we can see the function only increases from there. So y is more than 9. or
Yep.
f of x is more than 9.
Yep. It's f of x more than 9. And there you have it. That's the answer. Simple, right?
Mhm. Note to viewers that because
All
it says
right. So
x
for
is
the
more
next
than
question.
0
Oh,
and not yes, David? Oh no. Ah, yeah, just noting to viewers that it says x is more than 0 but not equal to. So that means your range is also just more than or less than and not equal to. So that kind of transfers over if any of you are confused about that.
hello.
Yeah, yeah, I can hear you.
All
Your
right.
camera's fine.
All right. All right. So next question. Explain why f has an inverse. So what does it mean when a function has an inverse, Yugen?
So that means when you, well, get the inverse of the function, that function remains one to one, and it still follows the rules of like any normal function. David? All right, I think he's disconnected. We'll just wait a minute or two. Yep, we'll just wait for him to join back. David says his Wi-Fi is disconnected. So, no, he's back. He's still having trouble joining. This might take a while.
Hey,
Hey, Devan.
hello, hello. Let me just go back again. I'm really sorry about that. So, as you said before, a function can only have an inverse, has an inverse, if they're one to one, correct?
Mm-hmm.
All right. So, as you can see here from our graph, you see that the function is one to one. Therefore, we can just write because f is 1 to 1 under the domain. And that's it. Simple, right? All right.
Yep.
Next one. Find f inverse. So how can we find f inverse, Yugen?
So the inverse of a function is always when the x and f of x switch because it's
Mhm.
reflected on the line y is x. So you can have x equals 2,
Yes.
2 times f of x plus 3 all squared, and you just solve
Okay.
for f of x.
Exactly. So let's solve it.
David?
Move 3 here aside to f
Oh,
of
okay.
x. Root x minus 3 and divide by 2. Root x minus 3 divided by 2. Okay. This is the answer, correct?
Yeah,
Okay.
yeah.
That's the answer. Right. Next question. State the domain of f inverse. So, for those of you who don't know yet, let's say you have your f here, you have your domain, and you have your range. Then you find your f inverse, and you have your domain again, the f inverse domain, and his own range, of course. So here's the thing: if you invert functions, the the f inverse the f inverse range will be the previous guy's domain, the f's domain. So
Mm-hmm.
so you can see that they switch roles. What was the domain before becomes the range, and what was the range before becomes the domain. So let's apply that rule here. Uh, that means the domain of f inverse is the range of f, correct? The range of f.
Mm-hmm.
What was the range of f before?
It was f of x is more than 9.
Hmm. So that was the range of f. But if you want to write the domain of f inverse, that means we have to write x greater than 9, like that.
Mm-hmm.
Okay? Is it clear, Yugen?
Yeah, yeah. That's
Okay.
everything is clear.
All right. So next question. Given that g of x is equal to ln of x plus 4 for x greater than 0, find the exact solution of fgx is equal to 49. So what's fgx?
That means you put your g of x, as your x for your f of x.
All right. So let's do that. That means f of gx right here is just, what was x before? 2 of x plus 3. So we have 2. Instead of writing x this time, we'll have to write gx because gx is our input. Is that right, Yugen?
Mm-hmm.
All right, then we have plus 3. Everything is the same. And we equate that to 49. Now we just have to solve it. And we have to square root both sides again. 2gx plus 3 is 7. Minus and divide g of x. 7 minus 3 is 4. 4 divided by 2 is 2. Okay. Are we done yet?
No, we have to expand g of x and then find x.
Exactly. So what was gx before? It was ln of x plus 4. So we'll replace that. Ln of x plus 4 is equal to 2. And how can we solve this, Hugo?
We can raise both sides to as a power of e.
Exactly. So we have ln of x plus 4 is equal to e to the power of 2, or e squared. So
Yeah.
what's the reason of doing this? It's because the e and the ln will cancel. So for those of you who don't know yet, so e to the power of ln of anything inside the ln is just the x itself, whatever's inside the ln itself, correct?
Mm-hmm.
So let's apply that rule here. So the e and the ln cancels, and we have x plus 4 left. Is that correct?
Yeah.
Now we just have to make x the subject. E squared minus 4. And that's your answer. Is everything okay so far?
Yeah, everything is fine.
Anything you want to add?
For those of you who want to be maybe really careful, when you root 49, you will also get -7, but then you'd find that e to the power of -2 minus 4 is a negative number. And if you input that back into the function, you won't get 49.
Exactly. So that's correct. Right. So let's read the question. The diagram shows the straight line 2x plus y is equal to -5, and part of the curve xy plus 3 is equal to 0. So 2x plus y is here, the straight line. Xy plus 3 is the curvy line here.
Mm.
The straight line intersects the x-axis at the point A and intersects the curve at the point B. The point C is right here, lies on the curve. The point D has a coordinate 1, 0 right here. The line CD is parallel to the y-axis. Okay, sure. All right. So first of all, find the coordinates of each points A and B. So where's A? A is right here, B is right here. I think A is easier to find, is it?
Yeah.
Okay, so how can we find A?
So A, because it's intersecting the x-axis, y is 0. So you can immediately sub that into your line equation.
Exactly. So right here we just have to let y is 0. So we have 2x is equal to -5, and x is just -5 over 2. Therefore, the coordinates of A is just -5 over 2, comma 0. Is that right, Yukan?
Yeah.
Okay. Now,
So
what
yeah,
about
that's the answer.
point B? What about point
So
B?
that's when the line and curve intersect. So you'd have two simultaneous equations to solve, so you can
Hmm.
get a coordinate.
Okay. So let's do that. We have 2x plus y is equal to -5, and xy plus 3 is equal to 0. So what should we do next here?
So you have to substitute either one into the other. So if you look at the second equation, that's really easy to rearrange. You'd get x is -3 over y, or if you want to, y is -3 over x. It doesn't matter.
Which one do you use?
Let's just say x is -3 over y.
Okay, sure. -3 over y. Okay. So what's next?
So you'd have to substitute that into your first equation.
Okay. So we have 2 of -3 over y plus y is equal to -5. Okay. Let's simplify this a bit more. This will be -6y plus y. Okay.
Pop up.
Oh, sorry. All right. So from here, we can simplify this a bit more by multiplying y. Is that correct?
Yeah.
All right. So we have -6y. No, not 6y. Sorry, the y got cancelled. Plus y squared, and we'll have a -y here, -5y here, but we'll move it to the other side. So we have plus 5y is equal to 0. Is that correct?
Yeah.
All right. That means we'll have y squared plus 5y minus 6. Oh, it's a quadratic equation. You can use factorize if you know how to factorize this, or you can use a quadratic formula. So for me,
Yeah, but
I can factorize this I think.
mm,
Y plus 6, y minus 1.
yeah.
Is that right? Is it
Yeah, that's
correct?
right.
All right,
Mhm.
that's good then. So we'll get two values of y. We'll have y is equal to -6 and y is equal to 1.
Mhm.
Now the question is, We got two y values, but there's only one coordinate b, one b. So which one's correct? What do you think?
Um, so we can see that our coordinate b is in the negative y section. So we have to reject the positive answer.
Exactly. So that means we don't care about y is equal to 1, but we only care about -6. All right. Are we done with the question yet?
No, you have to substitute that back into your x equation
Okay.
to
So that
get
means we
the
have
coordinate.
exactly. So we have x is equal to -3 over -6, which is just half. That means our b coordinate right here is just 1 over 2, comma, -6. And that's it. That's your answer for this question. Okay. Everything okay so far? Any
Yeah.
mistakes? Not done? All right. It's good to know. Right. Next question.
No mistakes. I actually made a
Okay.
mistake. If you go back to the
Yeah.
previous one, I just realized that uh, no, the question before
Oh, before?
that if you do get yeah, the last one, you do have two answers, but one of they both give you the 49, but one of them is because it's negative is just out of range. So you have to
Oh,
check for answers within the range. That's all.
yeah. So
So like just so
be
viewers are clear on that.
okay. So be careful of the domain and range. That's it, right? Basically.
Yeah, that's it. That's it.
Okay.
Your other one is fine.
Okay. So thank you for that, Yugen. And let's move on to the next question. Find the area of the shaded region, giving your answer in the form of p plus ln q, where p and q are positive integers. Okay, sure. So let's take a look here. We have to find the shaded region.
Hmm.
So what can we do? What's our first step?
So we can see that the region is compound. It's under the two different curves. So at the point B, before it, into the negative section is just a triangle. And then from B to C, it is under the curve x, y plus 3 is 0.
Hmm, exactly. So to make this easier, let's put a line here, right? You would do that too, right? Yugen?
Mm.
All right. So we have a line here. And so the first area on the left side is just a triangle, correct? Right angle triangle, actually.
Hmm.
So if you because this is a right angle triangle, we can just do the triangle formula, half times base times height. And what's the length here? What's the length right here?
So the length is the difference in um, x coordinates from A to B.
Let me
So
write
from
them
A,
down.
it's negative 5 over 2, and then B is
Yep.
negative half. So the base is 3 because it's half minus negative 5 over 2. And then the
Hmm.
height is the difference in y values, which is 0 to 6. So it's just 6.
Okay, exactly. So right here we'll have. Uh, so let me draw the triangle again. Sorry, I'm not good at drawing. So our height is just -6, and our base is half minus -5/2. Is that correct? Which is just
Yeah.
3. Is that right?
Yeah.
Okay. But because we just wanna find the area, we don't care about the negative here. So I just delete that negative. And so let's use the triangle formula again. The area of the triangle. So half times 3 times 6 is just 9. Is that right?
Yeah.
All right.
Yep. That's right.
Okay, so we found our first part already. We found that this part right here is 9. Now we just have to find what this part is. So how can we find this one? This one looks scary.
So, well, we already have a line equation and we have a bounds for x. That's 1.5. So we
Hmm.
have a definite integral from half to 1 of, and if you solve for, let's say, y, which is negative 3 over x, we can just integrate it with respect to x
Mm,
because we're going
exactly.
from the curve to the x-axis.
Exactly. All right. So let's do that. So we have the integral of half to 1 of -3x. Don't forget the dx. All right. So -3 is just a constant. I'll just take that out of 1 and 1 over x dx. So if you remember, the integral of 1 over x is just ln of x. We have ln of x half 1. Is that correct?
Mm-hmm.
You have to evaluate it when it's at 1 and when it's at half. All right, so let's do that. -3. So first we put when x is 1. So we have ln of 1. Subtracted by when you put x is half.
Mm.
So ln of half. Okay. Okay. Eugen, your microphone has a like that. Has a buzzing sound. Okay, he's out. He'll be back. So as you can see here, if you check ln1, uh, ln of 1 in your calculator, it'll just become 0. So we just ignore that. And let's expand this. So we have negative and negative. They'll cancel. 3 ln of half. Now by the sorry, Eugen's here. Welcome back, Eugen.
Welcome back. Is my microphone
Welcome
fine?
back to yourself, not me. Okay,
Oh
so
wait.
from the properties of logarithms, from the properties of logarithms, half is just basically 2 to the power of -1. Agree, Eugen?
Yeah, yeah.
Okay, by the properties of logarithms, you can bring the power in front. So let's do that. We have -3 ln of 2. And if you check this out in your calculator, it'll be a negative number. Is that correct?
Mm. Yeah, yeah.
And because we want the area, well, we just have to remove the negative here. We just have to get 3 ln 2. Correct?
Yep, that's correct.
All right.
So
So we got the two separate areas, and we can just add them up. We have 9 plus 3 ln 2. All right. But is this our final answer?
no, the question wanted it in the form a plus ln no q plus p plus ln q. There's no
Hmm,
coefficient of ln.
exactly. So that means, again, by the same property, we'll bring the coefficient up to the power. So we have 9 plus ln of 2 to the power 3. 2 to the power 3 is just 8. I'm just going to replace it with 8. And that is your final answer. Is that right, Yugen?
Yeah, yeah, that's right.
Okay, that's an easy 6 marks. Let's move on to the next question.
True.
Okay. Given that this expression, and y is equal to this expression, show that dy dx is this, where a, b, and c are integers. Okay, sure. So let's do it directly. We have the y, and we just have to look for dy dx. So as you can see here, this is just a product of functions, right? So first
Mm-hmm.
function and second function. That means we have to use the product rule, right?
Yeah.
Okay. So if for those of you who forgot about product rule, well, maybe you just need some thing to recall. ddx of uv is the same as, I'll not write like this. This is quite confusing. I'll write like this. uv dash. It's the same as when you differentiate u multiplied by a normal v.
Pop up.
Oh, sorry. Added by a normal u with the derivative of v. Correct?
Mm-hmm.
Okay, so in this case, we have our u is just x squared minus 1, and the v is just square root of 5x plus 2. Though if you reverse it, it doesn't matter. You're just going to get the same answer. So let's do that. Let's differentiate x squared minus 1. What's the derivative of x squared minus 1?
That's 2x.
2x. Then multiplied by 5x plus 2. Added by x squared plus 1, x squared minus 1, multiplied by the derivative of this square root. So what's the derivative of square root of 5x plus 2?
5x plus 2, that's just 5. Oh, with the root of 5x plus 2, then you have to use the chain rule. Devan?
Oh, sorry, I got disconnected for a while. Sorry.
Oh,
Can
okay.
you repeat?
Uh, if you differentiate root of 5x plus 2, you would need the chain rule because it's just 5x plus 2 raised to the half power.
Exactly. So that means, uh, so let's recall for a while. The dx of root x is just 1 over 2 root x, correct?
Mm-hmm.
That means when you differentiate, I'm sorry, I'll delete this for a while. Differentiate 5x plus 2, you would have to multiply by the derivative of the inside, which is just 5, correct?
Mm-hmm.
Okay, so we have 5 divided by 2 square root of the same function inside. Alright, so let's put that in. 5 over 2 and 5 is plus 2. Okay, looks complicated, does it?
Mm-hmm.
But it's okay. So how can we simplify this, Yugen?
Ooh, we can change the first expression
Mm-hmm.
into fraction form where the denominator is also 2 times root of 5x plus 2.
Exactly. So let's do that. The whole fraction and the whole denominator is just 5x plus 2. And that means we also have to multiply this term by 2 times square root of 5x plus 2, right?
Mm-hmm.
So we have 4 because 2 times 2, 4x, multiplied by 5x plus 2. Multiplying a square root by a square root will just give you power 1 plus x squared minus 1 of 5 to the bracket 5. Okay, so let's expand this. So we have 20x squared plus 8x plus 5x squared minus 5. Make sure not to forget anything. And we just have to simplify the top. 20 plus 5 is 25 plus 8x. They're low, they're low. And that's it. Are we done, you good?
Yeah, yeah, that's our final
Okay.
answer.
So make sure that you get positive integers. Sorry, not positive integers. Just get integers for the a, b, and c, and then box the answer, and we're done.
Hmm.
That's easy 5 marks right there. All right, next question.
Mm-hmm.
Find the coordinates of the stationary point of the curve of the same function for x greater than 0. Give each coordinate correct to 2 significant figures. Okay, sure. So we found uh, the dy dx. Why do we need dy dx? Because we're looking for a stationary point. That means if we want to look for a stationary point, we would have to find dy dx equal to 0, correct?
Mm-hmm.
All right, so let's do that. 25x squared. I don't remember the expression. Plus 8x minus 5 over 2 squared of 5x plus 2. Okay, we have to equate this to 0. That means we're trying to look for what's the x value that would make the function have a stationary point. Is that correct, Yugen?
Yeah.
All right. So let's solve this. We can multiply both sides by the denominator. We'll just cancel it out. And now we have a quadratic equation. Can you use your calculator on this, Yugen?
Yeah. I can tell you now that you can't factor it. So if you're not sure, like if your equation is factorable or not, just put it into your calculator. And if you get some wacky value, then of course you're gonna have to show that you're using the quadratic formula. Anyways, your first value is 0.31. It's
So
at
we
two
have,
decimal place, right?
yep, it's 2 decimal place. 2 significant
Okay.
figures.
Oh, okay. Yeah, 0.
0.31,
And your second is negative 0.63.
negative 0.63. But let's look at the question again. It says that for x greater than 0, that means we'll have to reject the negative one. Correct. Is that correct?
Yeah.
Okay.
Yeah.
So we have the x value. Are we done?
No, we
Why?
must put that back into our function and then get the coordinate.
Exactly. Because the question asks us to find the coordinate, not only the x coordinate. That means we have to put it back into the function. And yeah, why not? You can just put in the calculator for that. Put put 0.31 here, 0.31, then 0.31. And you can get your y value. What's the y value, even?
It's negative 1.7.
1.7. Okay, so that means the coordinate is just 0.31, comma negative 1.7. Is this the final answer?
Yeah, that's the final answer.
Okay, so easy 3 marks. Sorry, I forgot to delete this one. All right, so determine the nature of the stationary point. All right, so what does it mean when you're trying to look for the nature?
So you're trying to find out if it's a minimum or maximum point.
Uh, okay, so when a minimum it'll look like this, correct? Minimum and maximum look like this, correct?
Yeah.
All right, so how can we find this?
Mm-hmm. One way is using the sign test, which is just the easiest way. So you know your stationary point is at x is 0.31. So you can take a value slightly less and slightly more to see what your dy dx would equal to.
Okay, so that's 5. All right, so let's do the sign test. So when x is at 0.31, the gradient is 0, correct?
Mm-hmm.
All right. What about if it's less than that?
So if it's less than that, we can take a value just slightly less. So like 0.30. And that value is it's a negative value.
Negative, okay. What about when it's higher, a bit higher?
And if it's a bit higher, it's a positive value. So
Okay,
yeah,
so
if you
it's
put 0.23, you'll get a positive value. So if you can draw like the lines for it, you'll see that when it's decreasing and then it stops and then it goes back. So that
okay.
is a minimum point.
Minimum. Okay, so just for our answer, minimum. And don't forget to box the answer. Ta-da! 2 marks.
Mm-hmm.
Okay, next question. A vector question. Okay, sure. The diagram shows a triangle OAB, this one, such that OA is A. Here's OA. And OB is equal to B. OB is right here. Okay. The point P lies in OA such that OP is equal to 3/4 of OA. So here's P, 3/4 of OA. Okay. The point Q is the midpoint of AB. Right here, there's Q. The lines OB and PQ are extended to meet at the point R. Find in terms of A and B the vector AB. So how can we do that?
So you have the vector from O to A and from O
Mm-hmm.
to B. So you can kind of connect them. From A to O, it's negative A. And from O
Yeah.
to B, it's positive B. So negative A plus B is just B minus A.
Okay.
And
Exactly.
that's
So
just something that you can write down. No,
yeah,
no
we just have to
working.
write down. Oh, sorry, wrong. All right. So we have B minus A. So when you write vectors, don't forget the squiggly line below it. Is that correct, Yugan?
Mm-hmm.
Yeah. So we gotta write the squiggly line to show that it is a vector. And yeah,
It's
this
not
is our answer.
really that necessary, right?
Yeah,
Um,
but just to emphasize.
pop up, by the way.
Yep. Okay. Okay. So that's an easy 1 mark. Thanks for the 1 mark, I guess. So next one, PQ. Give your answer in its simplest form. So we have PQ right here. So how can we find PQ? Let's take a look. That means I can go PA and then AQ, correct?
Mm-hmm.
Okay, so what's PA?
You know that O to P is 3 over 4 O to A. So that's just 3 over 4 A. So therefore, your P to A is just 1 minus A minus 3 over 4 A, which is 1 over 4 A. David? I think he disconnected.
Yep, I am
Oh,
back.
okay.
Sorry. So as Yugen said, if this path is 3/4, then the leftover path is just 1/4, correct?
Mm-hmm.
All right, so we have 1 over 4a, 1 over 4a. That is our PA. Let me delete this one. And what about our AQ? So from the question, it says that Q is the midpoint of AB. What's AB? We found what AB was. That means we just have to divide by 2 or just half it, correct?
Mm-hmm.
All right, so we just have to add the half of B minus A. Okay, we can just simplify this. Let's expand and simplify. Expand, sorry. You see there's the two A terms here. So we have half B. 1/4 minus 1/2. That's negative 1/2, is it?
-1/4.
Oh, sorry.
Yeah.
Negative
If
one.
any of you are a bit confused, you can change the denominator. So -1/2 is -2/4, and then 1 minus 2 is -1. So you get -1/4.
Exactly. Okay, so that's your final answer, right? You good?
Mm-hmm.
All
Yeah,
right.
yeah. That's our final answer.
Okay, so that's 4 marks in total. Okay, next question. It is given that NPQ is equal to QR and BR is equal to KB, where N and K are positive constants. Okay, find QR in terms of N, A, and B. Okay, so N NPQ is equal to, so I'll write here NPQ is equal to QR. And what's the other
Mm.
one? BR is equal to KB. Okay, we need to look for QR in terms of A and B. Do you know what PQ is?
Yeah, we just
Yeah,
solved it.
exactly. So that means we just have to replace PQ with what we found before, right?
Mm-hmm.
So that means we have N multiplied by half B minus 1/4 A. So yeah, this is basically our PQ before, but we just replaced it. And there you go. That's your 1 mark again in boxing answer. Okay, next one. Find QR in terms of K, A, and B. So how can you find QR? QR is right here. This is QR. So how can you find QR? What do you think, Yugen?
QR again in terms of B. So you can have R to B and then B to Q.
Exactly. So I can go from QB, then BR, correct?
Mm.
All right. And what's QB?
QB is half of A to B, which is half B minus A,
Okay, so we
half
have
bracket B minus A.
A. Okay. What about BR?
BR, they gave it as KB.
Right here, right?
So, mhm.
So you just have to replace it. Plus KB. All right. And that's it. You can just box the answer here. That's it. That's free 2 marks.
Mm.
Hence, find the value of N and of K. Okay. So since we want to find N and K, we can equate. You see that both of these are QR. Is that right, Egan? Both of these are
Mm-hmm.
QR. That means they have the same path, the same vector. That means I can,
Mm.
if I equate them, they should be the same.
Yeah.
Correct. All right. So let's do that. We'll equate them. And sorry, it's too big. And I'll just multiply everything here. Sorry, not half. Writing half. Is equal to half B minus A plus K. Okay. So we'll just expand this. And let's try not to make any mistakes. Plus KB.
Half
Is
A
everything
plus
correct here?
KB. Yeah, that's right.
All right.
And
So
then
what's next?
if you really want, you can group your B terms together. So it's just half plus K times B, but that's not really that necessary. Over here, you can just compare terms. So all your vectors of A only in terms of n, so you can make one equation and solve that.
Exactly. So this is comparing coefficients method. Because these two vectors are the same, that means their coefficients has to be the same. Is that correct, Yugen?
Yeah, that's correct.
So we have in the left here we have we have n over 2 is equal to, what's the b here? We have half n k. So we have half k. What about another equation? We have this one right here. We have negative n over 4 is equal to negative 1 over 2 from here. So we got two equations, two variables, two equations. Perfect. And the easiest one would be to solve this one, right? We just have to multiply negative 4. We'll get n is equal to 2. Is that right, Yugen?
Yeah.
All right. Then we can just put n in the first equation. We have 2 over 2 is equal to half is k. This is just 1. I'm assuming the right one. Put half on the other side and we'll get k is equal to half and n is equal to 2. Are we done?
Yeah.
All right.
Yeah, that's it.
Our final answer. Easy 3 marks. Okay, next question. A particle P moves in a straight line such that its displacement x meters from a fixed point O at time t seconds is given by x is equal to 10 sine 2t minus 5. Okay. Find the speed of P when t is equal to pi. How can we find the speed? They only give us the displacement.
So if we have an equation for displacement, if we differentiate it, we can get an equation for velocity.
Exactly. So that means we have to find dx dt, correct? Dx dt. So we'll have the derivative of sine is cosine. And because there's 2t inside, we have to do the chain rule. Derivative of 2t is just 2. So 2 times 10 is just 20 times cosine of 2t. And the derivative of a constant is just 0. So we're not going to write that. When t is pi, so when t is pi, we have dx dt 20 cosine of 2 pi. What's cosine of 2 pi?
That's just 1, so it essentially cancels.
All right, so that means 20 times 1 is just 20, and that's your answer. Ta-da! Is that right, Yugan?
Yeah, that's it.
Find the value of t for which p is first at rest. Okay. So how can we find this for which p is first at rest?
So that's when your velocity is 0.
For when our
which
velocity
means it's
is 0,
basically like not moving.
Exactly. So we found our velocity right here. So we have 20 cosine of 2t is equal to 0. We have to equate it to 0 because it's at rest. There's no velocity. So let's do that. How can we find this?
So, well, the 20 doesn't matter if we divide both sides by 20.
Yeah.
And then pop up. And then we take the inverse cosine of 0.
What's the inverse cosine of 0?
Which is pi over 2.
Pi over 2, okay. We have pi over 2.
They're asking for value of t, which is first at rest. So we just have to find the smallest positive value, that's just pi over 2. And if we divide by 2, that's pi over 4.
T is equal to pi over 4. Now are we done?
Yeah,
we're done. Okay. And that's our answer. All right, next question. Find the acceleration of p when it is first at rest. How do we find acceleration?
We can just differentiate our velocity.
That's correct. So we have dv
with
dt.
respect to time, of course.
Or some of you may see it as d square x and dt square. Second derivative of x, correct? That means we just have
Mm-hmm.
to differentiate this again. So derivative of cosine is just negative sign. And based on the chain rule, we have to multiply by 2 again. We have negative 4t sine of 2t. Is that right?
Yeah, that's right.
Okay. Now, we found that what t was. We just have to plug it in. T is equal to pi over 4. Correct?
Mm-hmm.
Then we just have to plug it in. It's negative 4t sine of pi over 2. Because the 2 and 4 cancels.
Mm-hmm.
And what's this?
And sine pi over 2 is just 1. So you'd get
Okay.
negative 40.
Alright, so negative 40 it is. Thank you for the marks.
Did they give units?
No units. Though if you want to put
Oh,
units,
okay.
it's okay. You can put like meter per second square. This one is at seconds, and this is meter per
Mm.
second. If you want, it's okay.
All right.
Okay.
Usually yeah, they gave it as meters. All right.
Okay.
I usually put units even if they don't ask. It's usually good practice.
Okay.
So that's
That's good.
for viewers who really want to.
Sure. All right. So next question. The diagram shows velocity time graph for particle Q traveling in a straight line with velocity v at the time t. The particle accelerates at 3.5 meter per second square for the first 10 seconds of its motion and then travels at constant velocity v for 10 seconds. So this is v right here. Okay. The particle then decelerates at a constant rate, yeah, straight line, and comes to rest. The distance traveled during the interval 20 to 25, here, this part, is
Mm-hmm.
112.5. Okay. Find the value of v. Sure. So let's take a look at the question again. The particle accelerates at 3.5. That means the gradient
Mm-hmm.
of this line is 3.5, correct? Put
Yeah.
m here. M is 3.5. And and because it passes through the origin, that means that
Origin.
our equation would be v is equal to 3.5t, correct?
Yeah, correct.
Now, you see, it reaches this v value when t is 10. That means we just have to put t is equal to 10, correct?
Mm-hmm.
All right, so we have v is equal to 3.5 times 10, which is 35. 35 meter per second. Okay, that's our answer, 35.
Mm-hmm.
Agree?
Yeah,
Okay, find the
agreed.
velocity of q when t is 25. Okay, this is a bit harder when t is 25. Okay, let's.
Mm,
How can we do this, Yugen?
so the velocity when v is 25. So we have to find the gradient of this line.
Okay,
Um, and we have some information. We have that the area under the graph or the distance traveled is 112.5 meters.
yes.
Okay, so we know that the area of a trapezium is a plus b, which is the parallel sides, times the height, which is 25 to 20,
Which is just 5, correct?
divided by 2 is the area. Mm,
Okay,
your
exactly.
stream is frozen.
Is it frozen?
Oh, okay.
Okay, sorry. Okay.
Oh, no, it's moving now.
So from here, we know that the height here, this height right here, is just 35, correct?
Mm-hmm.
And by what Eugen said, the area is 112.5. We can use the trapezium formula for the area to find the height of this. Let's call it x. So we have the height here, the 5 plus 35 plus x over 2. Is that correct?
Mm-hmm.
Is equal to 112.5. Then we just have to solve for x here. Multiply 2 both sides. What's that when you multiply by 2?
225.
Okay, 225. Divide by 5. Well, I can't calculate that in my head.
45.
225. 45, okay. 45. You just have to put it in your side.
Then,
X
yeah, I
is
think you can do that yourself.
of course. I don't think I'll be taking additional maths if I cannot do that. All right, so that means our height is just 10. That means the velocity is just 10. Well, yeah, it's just 10 right here. Okay, you can put meter per seconds if you want. Find the value of t when q comes to rest. How can we do that? Find the value of t when q comes to rest. The particle q comes to rest.
So over here, you can use the gradient, uh, because now that you know the difference in height, you can find the deceleration,
Mm-hmm.
and then you know that your change in speed over time is your deceleration.
Correct.
So you can use that to find when v is 0.
All right, so we'll have to find the gradient of this, correct? This line.
Mm-hmm.
All right, so we have two coordinates that we can use. We have 20, 35 and 25, 10, correct? Is that correct?
Yeah, correct.
All right, so we have, let's find the gradient first. And this 35 minus, I can't remember.
10.
Okay, 10 minus 20 minus 25. This is 25 over negative 5. So that's just negative 5.
Mm-hmm.
Okay, now let's find the equation of the line. We have y. I'll use y instead of v and t. Not make it not very confusing. It passes through 25 and 10. So let's do that. We're gonna use this formula, by the way.
Mm-hmm.
If you don't know, this formula means you have a grade. You can instantly find the equation of the line just by putting the gradient and the coordinates that they pass through. Is that correct, Egan?
Yeah, that's correct.
Okay, so we have negative 5. The gradient is just negative 5 minus, right here we have 25. Though you can also use the other coordinate, but I prefer using this one. Okay, and we just have to solve for when y is equal to 0, correct?
Yeah, that's correct.
Okay, so we have 0 is equal to negative 5 x minus 25 plus that. Okay, I'll divide. Wait, I can put this to the other side first. We have negative 10, negative 5. Okay. Oh man, I barely have any space anymore now. We'll divide both sides by negative 5. We have 2 here. So we have x minus 25 is equal to 2. And of course, x is just 27. And therefore, the answer is
Mm-hmm.
just 27. And that's
Yeah.
it.
You could also do, because that's the deceleration, you can do negative 5 equals to change in speed, which is just 35 because it's all the way until 0, divided by time, correct?
Yep.
Could you also?
Wait, sorry, like what?
Wait, no, you just get 7.
Oh,
Uh,
okay.
because your uh, pop up, because your
Oh,
acceleration is change in speed over time, could you just do your 35 minus 0 over t is negative 5?
35 minus 0
I mean,
over
you'd get
2.
7. So that's a different answer. Oh, wait, no, because it's 7, the change in time is 7. So you can just add 20
Yeah, 20
and
plus
you'd get
7.
your final answer. I mean,
Yep. That works too.
so yeah,
Right.
for the viewers, that's an alternative way to do it. Yeah.
Okay, that's a good way to do it. But you'll get 27 at the end too. That's a good one. Okay, let's go for the next question. Solve tan 3x is equal to negative 1 for in this domain. giving your answers in terms of pi. Okay. So first of all, what I like to do is that I'll multiply 3 to this inequality. So we have 3 pi over 2, 3x, and 3 pi over 2. Is that correct, Vegan?
Mm-hmm.
Okay. That means when I take the inverse of this, the inverse tangent, sorry about that.
It's
So
okay.
when I take the tangent inverse of this, we'll have 3x is equal to tangent inverse of -1. Is that correct?
Yeah, that's correct.
I just have to find the values of tangent inverse -1 that's between this domain. All
Mm.
right. So what's the tangent inverse of -1? I think it's negative pi by
Negative.
4.
Yeah.
Okay. So because of the periodicity of pi of tangent, we can add pi any integer multiple. Is that correct,
Mm.
Egan?
Yeah, that's correct.
And we just have to guess the. You can just put in your calculator and try any integer that. Make sure when you add them up, they have to be between this.
Mm.
Okay, so of course negative pi by 4 itself is in between. What else?
If you
Negative.
have, yeah, you can try like k is 1, k is 2.
Hmm?
You would get, if k is 1, it is just pi over
It's 3 pi
3,
over
3
4.
over,
Yep.
3 pi over 4. But that's
And
out of the range, isn't it?
it's still in the range. 3 pi over 4 is less than 3 pi over 2.
Oh, right. I.
Yep. It's okay. And the next one is if you put -1. Oh yeah, it is. Negative 5 pi over 4 is still under the range.
Mm-hmm.
All right. So this is our 3x. We have to look for x. That means we just have to divide both sides by 3. We have x is equal to negative pi over 12. X is equal to pi over 4. And negative 5 pi over 12. And these
Mm-hmm.
are your answers. Agree with it?
Yeah, agree.
Okay. That means these values are when the function is 0, correct? Sorry, when the function is -1. Is that correct?
Yeah.
Okay. Now use your answer in part A to sketch the graph of this expression in the same range as this. I think you can already see something here. On the axis below, show the coordinates of the points where the curve meets the axis. Okay. So first of all, okay, I see. So if you want to look for where the curve meets the x-axis, that means I just have to equate this to 0, right?
Mm-hmm.
We have
So that's
12.
when it meets the x-axis, yeah.
0, correct?
Mm-hmm.
But if you take a look and rearrange, you'll get the same expression as before. That's what the previous question is.
Yes.
That means, and we've already found the answer. That means the function has to pass by these three x coordinates, right?
Mm.
That means let's take a look where negative pi over 12 is. Negative pi over 12. Let's see.
Yeah,
This
it's
is
the first notch to the left.
okay. And what else? This is negative 3 pi over 4, is it?
E-
Wait, no, there's
yep.
no, it's not negative 3 pi over 4.
No.
My bad. Oh, it's
The
5 over
negative 5 over 12.
5. Where's 3 pi over 4? Oh, wait, no, not 3 pi over 4. I'm sorry. Pi over 4. Yeah, it's just right here. Okay. That means the
Mm.
curve will pass through these 3 points, correct?
Mm-hmm.
All right. Now let's also take a look the asymptotes of tangent. So remember, if you the tangent graph, a normal tangent graph has an asymptote like this, right?
Mm-hmm.
Like there's an asymptote here.
Yeah.
Now, For this graph, because of the 3x here, the first asymptote is always at pi over 2, if this is a normal tangent graph. Because of the
Mm.
3x, you divide this by 3, so you have pi over 6. So every pi over 6, except for 0, will have an asymptote. Is
Mm.
that correct, Ethan?
Yeah, that's correct.
Well, actually, every pi over 6 plus any plus pi over 3k, because normally it should be pi over 2 plus pi. Okay. Then you just divide by 3.
Yeah.
All right. So let's try drawing the graph here. That means, where's pi over 6? Pi over 6 should be somewhere here, I think. And then another one right here. Okay, so let's draw the graph. I'm sorry, I'm not good at drawing.
It's okay.
Yeah, something like that.
Mm.
Now, are we done yet?
No, you haven't
Why?
marked where it meets the y-axis.
That's that's correct. So what's the y-axis here?
So that's when x is 0. If you
Mm-hmm.
sub that in, your tan term is 0, so you just get 4.
Okay, exactly. So this is just 4, and that's it. That's your. That's how you draw a tangent. It looks so ugly. I'm really sorry about that.
You can redraw it if you want.
Yeah. I mean, let me try. This here. Okay, I guess that's better.
Mm. All right.
It's much easier if you're using pencil, not an
Oh,
iPad.
yeah, yeah. You
Okay.
guys might have a lot more time to do it in the exam because you guys won't have any internet issues or anything. So,
I mean, that's true.
yeah, yeah.
And yeah,
And we're done. This session has been a bit more than 1 hour 30 minutes, and 1 hour 30 minutes is the time you guys get for this paper. So with
exactly.
all our disconnections, with all our issues, and on top of that, our explanations, we took, oh, it's 2 hours. Oh, we took 30 minutes less time. So you guys really shouldn't have a problem if you guys practice, if you guys watch these videos and really learn how to solve these kind of questions. So with that, we can conclude, and that's that for today. I hope
Yep.
all of you enjoyed the session and learned something valuable. And thank you all for joining. And thank you, Devan, for taking your time to do this session. And good night, everyone.
Yeah. Thank you also. Thank you, Yugan, also for being with me today. And thanks everyone. I hope you'll be in the next episode with us again. This. I'm sorry. I don't think I can do this Friday. We'll have to move it next week. I have to go somewhere this Friday. Okay. So next
All
week
right.
we'll have our next episode next week. So thank you everyone, and we'll see you next time. So bye bye. Good night.